Hey everyone, and welcome. Have you ever just stood somewhere, maybe in a huge canyon or on a wild, rocky beach, and just thought to yourself, how on earth did this get here? Well, today we're pulling back the curtain on Earth's greatest artists, these incredible, powerful forces that are always, and I mean always, sculpting our planet, carving, shaping, and rebuilding the very ground we walk on.
Just take a look at this. It's this magnificent, sweeping landscape of rock, layered up like a giant cake. And the simple, almost unbelievable truth? This entire thing was carved out, inch by inch, over millions and millions of years, by running water.
Seems kind of impossible, right? How can something as soft as water slice through solid rock on a scale this massive? Well, that's the big question we're going to tackle today. We're going to meet these sculptors of Earth and find out exactly what tools they use to create their masterpieces.
Okay, so here's our game plan. We'll start with this big idea of an ever-changing Earth. Then we'll meet our sculptors one by one. Running water, the master carver. Groundwater, the hidden artist. Ice, the great bulldozer, and of course, the restless waves that shape our coastlines. Let's dive in. So, first things first, we've got to wrap our heads around this one key idea. The ground beneath our feet isn't static. Not at all. It's a constantly evolving canvas. These powerful forces, geologists call them geomorphic agents, are always working, always reshaping the surface, in a process we call landform evolution. And this is really the core of it all. Landform evolution, it pretty much boils down to two key actions. You've got erosion, which is the wearing away and carrying off of material, and then you have deposition, which is just dropping off or building up that material somewhere else. Every single landform you see is a result of this epic tug of war between tearing down and building back up.
All right, let's meet our first sculpture. And honestly, it's the most widespread one, running water. In most places, nothing changes the landscape more than water flowing over it. From a little trickle of rain to a huge, powerful river. It is, without a doubt, the planet's master carver.
You know, when rivers are young, they're just full of energy, rushing down steep slopes. And all that energy is focused straight down, acting like a giant saw that cuts vertically into the land. Over tons of time, this powerful down-cutting action carves out these incredibly deep, dramatic valleys with super steep sides, like the gorges and canyons you see right here.
But here's where it gets really interesting. When that fast-moving water suddenly slows down and loses its energy, it switches jobs. It goes from carving to building. So when a mountain stream hits a flat plain, it just drops all the heavy stuff it's carrying, rocks, gravel, creating this fan-shaped pile called an alluvial fan. And when a big river flows into the ocean, it drops all its fine silt, building out a delta into the water.
Now, as a river gets older and the landscape flattens out, its energy isn't focused down anymore, it's focused sideways. So it starts to snake across the land in these wide, lazy loops we call meanders. This happens because the water on the outside of a curve has to travel faster, so it erodes the bank, while the water on the inside is slower, so it drops sediment.
And this diagram just shows that whole process perfectly. The loops get wider and curvier, almost touching. Then one day, probably during a big flood, the river just says, forget this, and takes a shortcut, blasting right through that narrow bit of land. The old loop gets cut off, sealed with sediment, and voila, you're left with this beautiful crescent-shaped oxbow lake.
Okay, our next sculptor is a bit of a sneaky one. It doesn't work on the surface with all that brute force. Nope, this one works underground, using chemistry. We're talking about groundwater, seeping deep into the earth, where it becomes this silent, incredibly patient artist, literally dissolving its way through rock. This whole process creates a really unique, almost alien-looking landscape called karst topography. It only happens in areas with soft, soluble rocks like limestone. See, as rain falls through the air, it becomes a weak acid. Think of it like a very, very slow version of vinegar dissolving an eggshell. Over thousands of years, this acid just eats away at the rock, creating this hidden world of caves and sinkholes. So on the surface, water finds little cracks and slowly widens them into sinkholes, which act like drains. Down below, it carves out these huge networks of caves. But it's not just about taking things away. As that mineral-rich water drips from the cave ceiling, drip by drip, it leaves behind tiny deposits that slowly form those icicle-like stalactites. And where those drips hit the floor, they build up into stalagmites. Sometimes they even meet in the middle and form a solid pillar. How cool is that?
All right, let's head to the coldest places on our planet to meet our most powerful and yet slowest moving sculptor, the glacier. These things are immense rivers of ice, so heavy that they literally flow under their own weight, acting just like the Earth's giant bulldozers.
Now, these glaciers work in two main ways. First, there's abrasion. That's where all the rocks and grit frozen into the bottom of the ice act like giant sandpaper, just scraping and grinding away at the bedrock below. And second, there's plucking. This is where meltwater gets into cracks, freezes, expands, and basically pries off huge chunks of rock that the glacier then carries away.
So, this bulldozer action creates two totally different kinds of features. On the one hand, as the glacier carves the land, it sculpts these dramatic erosional features. You get bowl-shaped basins called cirques and these incredibly sharp, pointed peaks called horns. But then when the glacier eventually melts, it just dumps all the rock and junk it was carrying. And that creates depositional features, like long ridges of debris called moraines and these smooth, oval-shaped hills known as drumlins.
And for our final sculptor, we're heading to the coast. The relentless, dynamic energy of ocean waves is constantly at work on the edge of the land. It's a never-ending battle, reshaping the boundary between continents and the sea.
And you really see two main types of coastal workshops. You've got high, rocky coasts where it's all about erosion. Waves just smash against the land with incredible force, carving out cliffs and other amazing features. Then you have the opposite, low, sedimentary coasts, which are all about deposition. Here, gentler waves and currents move sand around, building up things like beaches and sandbars.
All this constant work creates a stunning variety of landforms. On rocky coasts, waves find a weak spot in a cliff and form a sea cave. If that cave erodes all the way through a headland, it becomes a sea arch. And when the arch eventually collapses, poof, you're left with a tall pillar of rock called a sea stack. On sandy coasts, currents can deposit sand in these long ridges called spits or barrier bars, which can actually grow across the mouth of a bay, trapping the water behind them to form a calm lagoon. So let's zoom all the way back out. What we've seen is that our planet isn't some finished product, not even close. It's a living gallery, a dynamic canvas where water, ice, and waves are constantly working, sculpting, erasing, and creating new masterpieces. Every landscape we see is just a snapshot in a continuous process that's been going on for billions of years.
So, here's the real takeaway. The next time you're outside, maybe on a hike or at the beach, remember, you're not just looking at a place. You're looking at a story of immense power and unimaginable time, written in stone, water, and ice. The only question is, what stories are the landscapes right where you live trying to tell?